Good evening, Science Whizzes. We're here to do the second part in the scientific notation series, and now we're going to get to doing some math in scientific notation, specifically when you don't have a calculator or don't have a calculator that handles exponents or otherwise scientific notation. So let's look at that. We'll skip ahead through all the that we did this time and pick up here. The main thing that you need to remember is this rule from your math class about when you're multiplying exponents, if they have the same base, and everything in scientific notation is going to have the same base, the 10. All your exponents are going to be 10. Because they have the same base, to multiply exponents, you add. So this would be a problem that you might see, and I would ask you to do this without having recourse to a calculator, and we're going to break it up into, get a fatter pen there, I like that one better. Break this up into two parts, kind of the regular numbers, the decimal numbers, and then the exponents, the 10 to the whatever. So the regular numbers, we're going to treat them just like always. 1.5 times 6.0, and that gives us 9.0 now, though. Point zeros, like I said, we don't necessarily need those. I'm just putting them on there to keep track of where a decimal place is at. We're going to add our exponents. 10 plus a negative 2, that is 10 to the first. And we're going to put those together. 9.0 times 10 to the first. Now, before moving on, check to make sure that your answer is still going to be in proper scientific notation with one number in front of the decimal place, and we have this one, so this particular example is good to go. That's not going to be the case for all your multiplication, because I'm sure you can think of lots of multiplication problems that you do that will give you things larger than 9, larger than 9.9, where you'll end up with 2 digits in front of the decimal. So you're going to have to do some adjusting of the decimal to keep it in proper scientific notation. But we're going to go through the same strategy, multiplying the regular numbers, adding the exponents, and then we'll take a look at what we get. So 9 times 3, we get 27. Exponents, 10 to the second times 10 to the fourth. We'll add 2 and 4 and get 6. We'll put this together and we have this. Now, this is a mathematically correct statement for a problem, but it's not in proper scientific notation because we have 2 digits in front of the exponents. So we're going to need to adjust that by moving my decimal one place forward. So now I have 27. But I can't leave my exponent just as it is. Since I made this number one place smaller by one factor of 10, I need to increase my exponent by one factor of 10. So my 6 goes up 1 to become a 7. And that's all you'll ever have to do with numbers listed in proper scientific notation. You will never have to adjust them more than one power of 10 if your numbers were in scientific notation to begin with. And all the ones that you'll see on my assessment will be. Alright, now let's talk about division. You're smart people, so I'm sure you could figure out if we added exponents for multiplication. Now you just need to subtract exponents. And we're doing this again because all of our exponents are always going to have the same base, which is 10 for scientific notation. So this one, we've got 8 times 10 to the 5th divided by 2 times 10 to the negative 3rd. So my regular numbers are 8 and 2, so that's going to be 4. And I want to subtract my exponents. 5 minus a negative 3 minus a negative is a positive, so 5 minus a negative 3 gets me 10 to the 8th. I'm going to put those together. check for proper scientific notation form. I have one number in front of the decimal, so that's good, and this problem is finished. But just like with multiplication, you can end up with things not in proper scientific form. That can happen for division too. And in this case, you're going to get things less than 1, where you don't have a non-zero digit before the decimal. So if we look at this example, 2.0 times 10 to the 6 divided by 4.0 times 10 to the 4th. My regular numbers get me, that's a half, so 0.5. I want to subtract my exponents, 10 to the 6th divided by 10 to the 4th. 6 minus 4 is 2. So that's my exponent, and I'm going to put those together. I get 0.5 times 10 to the 2. Again, mathematically correct, but not proper scientific notation. So we're going to need to move this decimal back in this example. So I'm going to go from 0.5 to 5, or 5.0, times 10 to the... And again, we can't leave this exponent unchanged. I made the number larger by 1 factor of 10, so my exponent needs to get smaller, needs to go down by 1 factor of 10. Here's some examples that we did in class. I'm going to quickly run through these. So this one's a multiplication problem. My decimal numbers are 2 times 3, so that's going to give me 6.0 times 10 to the, get off of that, sorry guys, times 10 to the 8 plus 6, since we're multiplication, so that is times 10 to the 14th. I have proper scientific notation, so I'm done. Okay, next one, 1 times 10 to the 2nd times 5 times 10 to the 5th. 1 times 5 is 5. My exponents will be 2 plus a negative 5. So that is times 10 to the negative 3rd. Check for proper scientific notation. I have that, so that one is also finished. Third example, 6.0 times 10 to the 3rd times 3.0 times 10 to the 0. So I get 18 for my decimal number product. And 10 to the 3rd multiplied by 10 to the 0. 3 plus 0 is 3 times 10 to the 3. I check for proper scientific notation. I don't have it. I need to move the decimal. And making 18 into 1.8. Made the number smaller by 1 factor of 10, so I need to make my exponent bigger by 1 factor of 10. And that's the correct product for this one. Okay, last two are division. 9 times 10 to the 2nd, negative 2nd, divided by 3 times 10 to the negative 4th. So 9 divided by 3 is 3. Negative 2 minus a negative 4, so that's negative 2 plus 4, so 10 to the, whoops, brain fart, negative 2 minus a negative 4 is 2. Check for scientific notation, got that, that one's finished. Lastly here, 1 times 10 to the 3rd, divided by 4 times 10 to the 1st. That gets me 0.25. 10 to the 3rd divided by 10 to the 1. 3 minus 1 is 10 to the 2nd. Check for proper scientific notation. We don't have it. I'm going to have to adjust that to 2.5 times 10 to the, made my decimal portion larger by 1 factor of 10, so now I need to make my exponent smaller by 1. And that does it. Thanks, guys.